All right, recording for Caden, Lurie, and I think that is it. So we are on example 4. We're gonna finish this section today because I'm tired of it. Are we tired of it? Yeah, we're tired of it. Okay, so here's the deal. We have 2 proofs that we're gonna go through on the notes. You have 2 proofs for homework, and we'll probably go. I'll let you attempt them on your own, the 2 proofs on your own, and then we'll go through them together, and then we'll be done for the day, right? Like you will turn homework in at the end of the day, and you will not have homework tonight, which is good because we have games, right? Yes.
Do we have to do proofs on our test?
You have to do like 1 on your test, I think. Yes.
Only
Yeah,
1.
you'll be fine. You'll be all right. You're all right. Okay, so example 4 starts us off. That gives us all of our stuff that we need, and they ask us to do a flow proof. And I told you yesterday that like 99% of the time I will nix that instruction and say, let's do a 2-column proof instead. So that's what we're going to do. Okay. So I'm going to write over here. Here is my given. Here is my prove. And here is the diagram that goes with it. Okay. So given P is the midpoint of JK. P is the midpoint of JK. We are trying to prove that X equals 2. What? That's weird. Okay, so I have that diagram going on there. Given, prove, all the things. We may take like a different route than what they have going on here for their flow proof, but basically it'll end up being the same outcome. Okay. Do you remember how we start the proof? Yes. What are our titles? Statements, reasons. So we put statements on the left and reasons on the right. Yep, and you state your given first. So P is the midpoint of JK, and we put reasons given. That's where we start every single proof. We start with the given or a piece of the given. Sometimes they'll have like multiple parts of the given and we won't do them all at the same time, but we have to start with a piece of given to begin with. Good? Beautiful. Okay. All right. This is the diagram that we have going on here. If they say that P is the midpoint, let's just like spitball this here. P is the midpoint. What does that tell you? Yeah, JP and PK are going to be equal to each other. JP is equal to PK. Those 2 little bits are the same. Now, how do I know that that's true? You wrote it on your pink sheet. What tells me that JP is equal to PK? And so what do we call it? Definition of midpoint. Definition of midpoint tells me that those 2 pieces are the same. If that's the midpoint, then those 2 pieces are the same by definition of midpoint. Okay, now what? We know that those 2 pieces are the same. Now what should I do?
Now we have to,
because we're having to solve for X, right? Okay, so we got to get that involved. I want to solve, and I want to say that X equals 2. So I've got like my 2 little pieces here are the same. Like, how do I use that to solve for X?
X plus, substitute X.
Yeah, so like, what do we know about these 2 things? They're equal. So I have X is equal to 5X minus 8. And how am I able to say that? What did I do? Substitution. Substitution, right? I took the X and I plugged it in for JP, and I took the 5X minus 8 and I plugged it in for PK, right? Like I put them in those spots because that's what they're equal to, and so that is substitution. I plugged them in, okay? All right, now what?
Substitution again.
No.
Put 2 in for X.
No. I gotta solve for it. What should we do? If you had to solve for X here, what would you do? I'm going to subtract the 5X, right? Subtract 5X, subtract 5X. So my next step would look like what?
Negative 4X equals negative 8.
Negative 4X equals negative 8. Now, how am I able to do that?
Subtraction.
The subtraction property, right? Subtraction property says that I can subtract it over to the other side and it's there, okay? Now what?
Division.
Yeah, we do division. We divide by negative 4. So my next step will be X equals 2, and that is the division property. Okay? And then what? Is that it? Am I done? We're done. We've proved it, right? That's our last step. We've proved it, okay? So now notice one thing real quick. Our first step always starts with the given, right? But notice your last step should end up saying like X equals 2. That should end up matching up, but it's not prove over here, right? Okay? So the first piece, the reason is given, but the last piece is not the prove part of it, right? You actually have a name for how you get to the last piece. Does that make sense? Okay, there you go. There's our proof. Okay, good. Questions about that? All right, let's go to the next one. I don't know. Do you want to do the check? Let's do the check real quick. Let's do the check. We didn't do this morning, but we'll do the check. Okay. So we are given, and let's do it flow proof style because they have kind of a nice setup going on here. So let's see if we can do this flow proof style. I won't ever tell you to do this flow proof. We'll do it 2-column proof, but it's okay. We have given FG is equal to HK. So FG is this guy, HK is this guy. We know that they're equal. That's what we're given, right? So they have this guy and it's given. This is like my statements and my reasons right below. Then I've got a statement and a reason, and 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 a statement and a reason. Good, good? Okay, so here's the deal. They have, I don't know, let's go here. FG and HK are equal. That's given to us. And then they say we're going to use substitution to go to the next step. What are we substituting?
22 equals 4x minus.
Yeah, so FG, okay, but hold on. We got to keep it in the same order. So FG is going to go in that spot. So let's go 4x minus 6 is equal to 22. We'll keep them in the same order. So we're substituting the 22 in for the HK. We're substituting the 4x minus 6 in for that stuff.
Then
Okay.
add the 6 over. So
Okay, you add the 6 over. Okay, now, they do something weird. They do something weird, and I'm going to, show you what this is. Are you prepared? They do some weird things, okay? Here's what they do. They do 4x minus 6 equals 22, and to get the 6 to the other side, we would add 6 here, and we would add 6 here. Okay? That looks kind of weird, right? I would add 6 to both sides, and that is the addition property. Okay? It's like they add an extra step in there, which I don't quite understand. But if we add the 6 to the other side, does it turn out to be 4x equals 28? Yes. If I add the 6 over? They call that, it's like a cleanup step where we clean it up, right? We get rid of the 6's. Your cleanup step they call substitution, which is weird, right? Okay? They substitute -6 plus 6 ends up being 0, and then they substitute 28 in here, right? Like they clean it up. Got it? So their cleanup step is called substitution. Weird stuff, okay? The next thing that they do is, notice, 4x equals 28. They divided by 4, and they left it like that, right? They did 4x over 4 equals 28 over 4, right? And they call that division property. What's our last step going to look like? X equals 7, and what are they going to call it?
Prove.
Nope, it's not prove.
Proof.
Nope. It's, nope. It's like a cleanup step. Substitution. I don't know why they call it substitution. Substitution, right? Okay. They just sometimes do weird things like that. They call it substitution. It's the cleanup step. Good? Happy with that? Not so bad? Okay. All right. That was a flow proof. I like the 2-column proof style better. Do you? I do. Okay, let's do the last one. They want us to do this as a paragraph proof. I'm going to go ahead and do it as a 2-column proof. So I'm going to put the stuff up here. This is example 5. Here's what we are given. All this stuff right here. I'm going to put it up over here in this little box. We should have enough room. Okay. We are given 2 pieces of information. We know that C is between A and B. And we know that AC is congruent to CB. Those are 2 pieces of a given, and what we're trying to prove is that C is the midpoint of AB. That's what we're trying to prove. We don't even have a diagram for it. Woo! That's all of the stuff that we have. Okay? C is between A and B, and AC is congruent to CB. So if I draw a diagram, you guys can kind of see this in your head. C is between, right? If C was between, we don't necessarily know it's exactly between, but if we look at the second piece of given, they say that this has to be the same as that, so we do know it's exactly in the middle. Does that make sense? Okay? All right, so let's try to map this out using just like our logical thinking and show why that has to be the midpoint. Okay, so I'm going to start with statements. Statements and reasons. Okay, sometimes you only write one of your given piece of information down at once. And then you like try to like gather information from that and write more down. And then you use the other given piece of information. I think we need to use both of these at the same time, so I'm gonna write them both down together. Okay, so I'm gonna say C is between A and B, and AC is congruent to CB. And there is that. And that is given. Given. Okay? Yeah, so I know from here that AC and CB are congruent, but I think what I'm going to do in my next step is say that AC is equal to CB. Now, yesterday we talked about how like congruent doesn't necessarily mean the same thing as equal. Congruent means same shape, same size, but equal means the same length, right? Okay? So kind of a little bit of a difference. So how do I go from being congruent to being equal? It's on your pink sheet. Nope. Definition of congruent, right? 4 line segments. If they are congruent, then that means they're equal in length. So definition of congruent, that's what that means, right? Okay, now if AC and CB are equal to each other, does that mean that C is the midpoint? Yep. C is the midpoint of AB. Okay, and how do I know that? If AC is equal to CB, definition of midpoint. Yep. By definition, if they're equal to each other, then C has to be the midpoint. Okay. Good. Very good. That's it. That's all there is. That's only 3 steps there. So that one, I kind of prefer the first 2 proofs that we did because there's like an algebra bit involved. This one is just a little bit less satisfying, I should say, right? Okay. Not quite as fun as the algebra bit. Okay. All right. So here's what we're going to do. I'm going to give you a second to try. We're going to add 13 and 14. Okay. Add 13 and 14. See if you can come up with what goes in the blanks. I'll give you like a couple minutes to try working on those, and then we'll go through them together. So if you get lost, that's totally fine. Try to fill in as many blanks as you can. Okay. And then we'll reconvene in like 5 minutes. Okay. That work?
So these ones are like all 3 of them that we've been doing.
Kind of, yes. Especially 14. 14 is going to be really similar to the first 2 that we did because you have those 2 things that are like equal to each other. So go through and try it. Sometimes they do weird things. I don't know. But go through and try to figure out what they want for each little blank. Okay. We will reconvene here in like 5 minutes. Or whenever you guys say you're out. 13, 14. Yep, that's it. Those 2.
I know number 1 on 14.
On 14, you know number 1?
Yep.
Given?
Yep.
Okay.
This is the top algebra.
You betcha. You betcha.
Yeah, you guys got big shoes to fill.
Uh-huh. Oh, boy. There's something.
Do you want to talk to Richard that you asked me for help on the account?
So I just got home this morning. Actually, no, I was born.
Oh, I was so shocked and honored to be
Well, like-
I was sick. And I knew we worked on the couch the previous whatever
So are
day
all
that was.
these
And
that, you know, the reason?
Bruh,
Uh-huh.
I just got too much going.
Is that what we were talking about earlier?
What? What do you mean?
Like, where do we get all of these?
So a lot of those come off of like these right here,
Oh,
this
okay.
sheet. Some of them is like substitution, so that's like a
We
thing.
just know.
We had like the subtraction property or division property.
Okay.
It's just like how do you know that you're able to do that? Well, because we just substituted or whatever, you know. Sometimes it's weird. I don't know. I'm gonna come over here and I'm gonna fill this board out maybe, because I haven't done it for the last 2 days. Ooh. Set that there so it's not so loud. I'm still trying to record, so I have to keep the screen going.
But I do acknowledge there are right and wrong ways to use it, but I think there is. Well, I was looking at the adult. I'm scared of the future generation of doctors. Are they gonna know what they're doing? What are you doing? Being is regular, like what if you just get your med school by being, what if you don't even get into med school? I know, like just chat GPT. No, the future doctors and nurses, they're gonna get how to. I do everything on my own. Sometimes my grandma might be really bad and I do it. Yeah, not that much. Like, I know what I like. Sometimes it's like really hard for me to know, but like to put it in words. Yeah. That's like a little hard. I like ChatGPT, like gives me a lot of ideas to talk about. My most recent discovery on ChatGPT is I made an image off of like a shirt. So it like I was asked it for transparent background and like generate that. That was really cool. Like map, did that myself, plans, did that myself. Oh, the size of that is something. But also things like study. Recommended policies.
All right, we get anything figured out?
Well, like, you can
Maybe.
summarize this website or whatever the website is. That's what I do, so I don't have to read, like, if I'm looking for information. Summarize it.
Order and speech, she's gonna have it look at my speech and say, if you were a speech judge,
I don't know why.
what would you? That's some dedication.
It is.
Cause like, I don't know what the definition of congruent segment is.
Right here. Definition of congruent segments. So if they're equal to, then they're congruent. Or if they're congruent, then they're equal to.
So,
So it's like you're going, like,
Just
when
makes
you're
them
doing this.
equal to each
Yeah,
other.
yeah, right.
so
So
FH,
midpoint theorem, yeah. And then you're equal to now,
Have you
right?
started?
And then you substitute each one of those in for there. So you did substitution. Now you're adding.
Where are we right
Okay,
now?
I did
Yep.
this.
Yeah. You're doing fine. You're doing fine. Yeah. Very good. We're getting it. Kind of. Yeah.
Those aren't even big.
The next one. Oh, the braids. They don't have to be. They feel great.
substitution? No, that's subtracting.
Shake your dreads. I feel a lot better.
Are we at a stopping point? Yeah?
It would be
We're not at a starting point yet either?
I thought
Okay. All right, let's see. So this first one.
Given, substitution.
Hey, given. All right, we got a given.
I turned that.
Given. What? This one? We're going over the questions right now. Go grab it. Okay, so just take a look real quick. We have how many pieces of given?
1, 2, 3.
We have 3 pieces of given. They only write the first one down here. The rest of the given's going to show up somewhere else, right? So they give to us. Let's check out what they're giving to us. SR is equal to RT. Okay. Well, if SR is equal to RT, then by the definition of midpoint, what's that mean?
You are the midpoint.
R is
ST and UT.
R is the midpoint, right? By definition, if these two are equal, then R has to be the midpoint. But wait a second. Isn't that what we were trying to prove? Isn't this guy one of the things that we were trying to prove?
Yes, but that's another.
Hey, but we're done with half of the proof, right? Now we got to get to the other part. Now we have to also prove that R is the midpoint of UV. Okay, so let's track our thought process here. In order for R to be the midpoint of UV, right? Take a look at this. R midpoint of UV. I need to at some point say that this guy is the same as this guy. So in other words, UR has to be equal to RV, right? in order for R to be the midpoint. I have to get to that at some point, right? Okay? Yeah? All right, they give me this on part 3. What's the reason for 3? Given. That's another piece of given, okay? So we just said that UR has to be equal to RV at some point, all right? Let me see what I've got. UR is equal to RV. Am I allowed to say that?
Yes.
Okay, if I look at, number 4. If I look at number 4, check this out. If I look at all 3 of these pieces, I'm going to circle them in pink. This guy along with these 2 guys, okay? Check this out. We have SR is equal to UR. I'm going to put that in place of SR. RT is equal to RV. So I'm going to take that and I'm going to put that in there. Do I end up getting this?
Yes.
Yeah, if I take UR and I plug them in there, and I take RV and I plug them in there, then this will read UR and RV are the same by substitution, okay? Now, if UR and RV are the same, if this guy is the same as this one, then what do we know? R is the midpoint. R is the midpoint of UV. Why do I know that? What's my reason for that? What goes in this one? Definition of midpoint. You got it. Okay. Kind of weird. Kind of funky weird. You don't like it. Okay. Good? Yeah? Okay. All right. 14. Here we go. We have that H is the midpoint right here. H is the midpoint. Midpoint. And we are trying to prove that X equals this. All right, here we go. So first one is, you should never miss that. You should at least get 1 point, right? Given. Okay, then by the midpoint theorem, everybody look at the midpoint theorem on your pink sheet. Midpoint theorem. If H is the middle, what does the midpoint theorem say? FH will be what? Congruent to HG. FH will be congruent to HG. That's what the midpoint theorem says, right? Now, some people put equal to, but that's definition of midpoint. For some reason, they're making us go out of our way and they're doing extra steps, whatever. But now we want to use the definition of congruent segments to say what? How do we go from 2 to 3? Definition of congruent segments says that if they're congruent, then they are equal. They are the same, right? So definition of congruent segments, if they're congruent, then they're equal in measure. That's what the next one should be. Now, if it were me doing this proof and I didn't have the blanks, I would have gone straight from here to here and used definition of midpoint, right? Whatever. For some reason, they're adding extra steps in. I don't know. Okay. All right. Now, how do I go from this step where I have the F's and the H's and the G's and all the stuff to these 2 things being equal? Nope. Substitution. We plugged these guys in for FH and these guys in for HG. Yeah, that's substitution. Substitution. Yeah. Substitution. I'm plugging stuff in. Okay, now we're to here. We're to number 4. Now what shall we do? They say addition property. You want to add the 5.5. So if I add 5.5 over to here, we have 2x and then what?
12.5.
Plus 12.5 equals 12x. Okay, there's that. Okay. All right, now what? They want to subtract 2x, right? So I have 12.5 is equal to 10x. Okay, and what's that called? Subtraction property. That's subtraction property. They say subtraction property of equality. That's like the full name of it, but subtraction property, right? Okay. Now, I would only go one more step. I would go straight to number 8, but they do a middle step. What's their middle step going to look like? 12.5 divided by 10. For some reason, they're doing that. Whatever. 10x divided by 10. I don't know why they do the division property like that. And then my final answer, x equals 1.25. What's that called? Substitution. I don't know why they... Substitution. I don't know why they do that cleanup step as substitution, but it's kind of weird. Okay? How are we feeling?
That's easy.
Super good.
You're like, we still don't like it, but it's okay. We'll make do. 14 was easier than 13? Yeah? Okay. I think so too. Even though it's more steps, I like the algebra part of it. Like this, I can follow.
Yeah, I feel like it's
Yeah.
Can you explain to me on step 4 for 13 on what you
on step 4 for 13. Okay, so I know, like sometimes I get to a certain point in my proof. We got through 3 and I'm like, I don't even know what to do now, right? So I know that my last step right here has to be this, right here. R has to be in the midpoint of UV. So sometimes I think to myself, okay, if R has to be the midpoint of UV, right? If this guy has to be exactly in the middle from here to here, then I have to be able to say that this part is equal to this part, right? UR is equal to RV. So I'm going to write that down on step number 4, and I'm going to see if that matches up, right? Okay? So if I write that down, I'm going to look at these 3 pieces together. So UR equals RV. I know that has to be my step, right? But how did I get from this and this to here, right? Well, let's take a look. If I start with this, let's just say we have this going on right here. Pencil. Let's say if I have this right here. SR is equal to UR. So I'm going to take UR and I'm going to put it right here. UR. And then RT is equal to RV. So I'm going to take RV and I'm going to plug it in there. So now I have UR is equal to RV. And that's substitution. We plug these guys into there, and then we can say that R is the midpoint. Does that make sense? Okay? So sometimes I use that as a strategy. If I don't know what I'm doing, I'll start from the back and work backwards, right? Like, what do I have to be able to say in order to say this last thing, right?
It would be substitution as your answer.
Substitution there, and then definition of midpoint, right? If these 2 are the same, then that means that has to be a midpoint. Yep.
Is
Okay.
this still the first cutting of white?
No, this is the second one. We have 4.
What time is it?
Second to 4. Okay. All right. Goodbye, Caden.